Hi, hope you're doing safe at home. So by now, I think you all know me. Anyway, I used to teach three lab sections of Physics 101, and one lab section is taught by Dr. Bettino. So if you are in her lab section, she will be available through Zoom if you need any help, and also she will be replying to your emails. So I'll be doing the recording of these videos for the labs. It is a new experience for all of us. And I hope these videos will helpful for you to work on your lab report. So please try to learn the things because it's really important. So in the first part of the video, the first video, I'll be talking about the theory behind this lab, and you will be seeing two other videos with the experimental part. So please watch these and work on your lab report. I try to keep these short as possible, but sometimes it may be a little long as 10 minutes. All right, so let's get started with lab 6. So it's about electric charges. So have you ever experienced this type of scenario? Getting an electric shock, like after you travel a lot, like especially in the wintertime, you might have experienced it, right? Walking, we will be collecting electrons into our body, right? And anytime when you're touching a metal, something like metal knob of a door, or when you are getting out from your car, you might be feeling like you got a shock, right? So that's what it is happening. So in the lab for this week, our main objective is to learn about the electric charges and its effect. So effects of electric charges, basically like if you rub different materials together, it can separate the charges. Okay, so and depending on which material you're using, so there are two types of materials like conductors and insulators. So also there are semi-conducting materials as well. So basically a conductor means a good material that can take these charges around, like it's possible to travel these charges in those conducting material. Insulators are holding charges, so it is not helpful for flow of charges. So basically different materials behave differently for electric charges. And also you might already know that like charges repel and unlike charges attract, right? All right, so there are two types of charges. Those are positive charges and negative charges. So basically positive charges are the protons and negative charges are the electrons. So Benjamin Franklin named these charged particles. So you know who's Benjamin Franklin is, right? Do you? So that's one of the founding fathers of United States. Well, so what is an atom? So let's learn about like what is a proton and what is a electron, or what are positive charges and what are negative charges. So basically, let's think about a hydrogen atom. So in a hydrogen atom, you know, like there's one proton and one electrons that orbits around the proton, right? So here we call this as a hydrogen atom. And if you look at the charges here, there's one positive charge and one negative charge. So they are in a neutral condition because there are no extra positive charges or extra negative charges. So they are canceling out their charges and they are in a neutral condition. So this is a hydrogen atom, which is electrically neutral. It's neutral. Then think about, in any way, if we can kick out this one of the electrons, it does have only one electron, and if we can kick this off from the orbit, then there will be only one proton left behind, right? So in the atom, we have only one proton because we took that electron away from this atom. So basically here, now you see like it is not an atom anymore because it's not neutral, right? So there's only one proton there. So we call this as a positively charged hydrogen. So it is a hydrogen atom, get charged positively. So this is a positive hydrogen ion, right? So this is a hydrogen which is positively charged. So we call this as the positively charged hydrogen ion. Well, we can also make this atom charged negatively. So you know what it is, right? So if you can bring more electrons into the shells, then you can make more electrons here than number of protons there. So here, if you bring one electron from somehow to the orbit here, so you will be seeing like there are two electrons and one proton. So this has extra negative charge there, so it is negatively charged, right? So there are extra electrons here than number of protons. So we call this as a negatively charged hydrogen ion. So this is a negative hydrogen ion, right? Well, how can we charge things? Then how can we going to bring negative electrons, or how can we kick off negative electrons? So you notice something here. So proton didn't change. Only thing that changing is the negative, right? So negatives are the only charged particle which is possible to travel around. So if you think about the household wiring and the electricity that's traveled, those are electrons basically. Protons are never traveled. Only electrons get moved in the conductors. So there are two methods that we can charge things. So we call the first one method is charging by conduction, and the other method is by induction. So here I'll be sharing you a little animation, but before that also, you know, like if you have positive charge and positive charges, they are repel, and if you have a negative charge and another negative charge, they repel as well. And if you have like unlike charges like positive charge and negative charge, they attract. So we need to know that idea as well to understand the charging by conduction and induction. So I'm going back to the one of other simulation here. So you see here, there's a balloon, right? So this balloon does have in this picture, it does have 4 protons and 4 electrons. So this is electrically neutral balloon, right? And if you think about this jacket over here, it does have a lot of electrons and protons, but if you count, the number of protons are equal to the number of electrons. So there are equal number of protons and equal number of electrons. So the jacket is electrically neutral, and balloon also electrically neutral. Then the wall also electrically neutral. So this is a wall here. Now what I'm going to do is I'm going to rub this balloon on the jacket. See, like when I'm rubbing, I can collect electrons onto the balloon, right? I'm not going to collect every electron, but a bunch. Okay, so now look at this. So the balloon does have extra electrons deposited in there. So the balloon is negatively charged now. And if you look at the jacket, it's positively charged, right? So if I let the balloon go, it travels towards the balloon because it's negative, positive attract each other, right? Now, here's the interesting thing. So the balloon is negatively charged. By doing this, I rub the balloon against the jacket, and so they touch each other. So by doing this rubbing, I charge the balloon negatively, and that surface charged negatively by conduction because it touches each other, right? Now, let's observe this. When I bring in this negatively charged balloon towards the wall, you see something that electrons on the surface of the wall get repelled, right? It's going away, leaving protons behind on the wall, right? So on the surface of the wall, it's positively charged. So if I leave the balloon here, it's get attracted to this positively charged surface. Now here, this charging effect, like the surface of the wall get charged by induction. It's not touching. I don't need to touch that or rub against. I just bring it closer to the wall, and it's the surface get positively charged. So this is called the charging by induction. Right. So in the experiment, we'll be experiencing both of these methods. So you'll be seeing like we'll be rubbing a plastic rod against fur, and then I will be bringing it to a metal sphere which is connected to an electroscope. So in the electroscope, you will be seeing leaves behave differently, and you're going to explain that. And in the experiment video, I'll be talking about that behavior a little bit in detail. Then in the third part of actually it is the second part of the experiment, you will be using a Van de Graaff accelerator. So that's a apparatus that we can use to collect charges onto one surface. So here in this Van de Graaff generator, you'll be seeing a real video with the real equipment. So you'll be seeing like there's a big metal sphere that's connected to a rubber tape here. So when we power up this device, actually this rubber band will be rubbing against this knob over there. So it will be collecting charges on the surface, and this comb will be collecting those charges on there. and then that comb is connected to the metal sphere there. So those charges, after it's get collected, the charges will be spreading around this metal sphere, right? So it's get positively charged. So if you have anything that attached to this one, it will be collecting those positive charges. So anything attached to the surface will be get positively charged. Well, I'll see you in the experiment part of the video, and then you may complete your lab report. So if you need help, myself and Dr. Bettino will be available through Zoom and also through